Thank you very much. So the presentation I'm giving you guys right now, I gave last week at a conference that Autodesk just threw on a new area of technology that's being called reality computing, which is what happens when you combine 3D scanning, computation, and 3D printing into one ecosystem. And one of the things that I've noticed is that there's a lot of new technology out there that a lot of us who are designers and engineers were never educated on how to use. And there's a big gap right now between pedagogy and technology, and people are not being taught how to incorporate new tools into their process. And so Meta-Modernism is an attempt at codifying these new technologies into a process in the hopes that we can encourage better and more informed design. So a lot of people are talking about 3D printing a great deal right now. It's getting a lot of hype. And everyone says it will revolutionize everything from fashion to cars. And Anouk will tell you about her dress here on the left when she speaks after me momentarily. But there's a lot of revolutionary things happening in the printing space right now. But a lot of it is severely overhyped. 3D printers are incredibly difficult, bitchy machines. Builds fail frequently. It's very hard for you to get them to do what they want. And we've got a big issue happening right now that if we want this big maker revolution of distributed manufacturing, we're going to have to learn how to make these machines useful for regular people so that a non-engineer or a non-designer can use these things to make something that is desirable. And that's an issue right now. And a lot of people in the industry keep waiting on this mythical killer app to come that's supposed to deliver that, to curate the experience, to make things easier for regular people to use. But where the hell is this killer app? Like everyone keeps talking about it, but there's very little that's being done right now to make it. And I think that we're kind of reminiscent of the homebrew computer club of the early 80s. That we're all, those of us who understand 3D printers and use them, we're huge geeks, we love the technology, we're willing to put up with the bad for the promise of the good in the future, but right now we're just kind of in a big engineering circle jerk. And originally when I had planned to give this talk, I was going to do this massive deep dive on all the amazing new 3D technology that's coming, from being able to print sugar, to print electronics, to 3D scanners that are making their way into new tablets and laptops that are going to be ubiquitous by year's end. And even virtual reality is getting here, and it's getting very cheap and accessible and exciting. But if I sat here and just talked about technology, that would make me guilty of the problem. The problem is those of us who are designers and engineers, we're trapped in one silo. We just geek out all day, not thinking about what's going on in the rest of the greater ecosystem. And these silos of how we do business in our normal economy are based on, the way we have done things in the past, where it takes high tooling costs, long lead times, lots of manufacturing and logistics. So, the behavior of business kind of dictates the pedagogy of design, and that's used to a really long cycle time. And that's caused us to be in a situation where we don't communicate a lot, and we don't think about, the downstream effects of our products or how to manipulate those products. Once engineering and design sort of come up with something, they toss it over the wall to each other a couple of times. That gets thrown over to the admins who say that they want to go build it, and then that gets sent down to manufacturing. If anybody finds something out about the product not working, you've got warehouses filled with product, and before any of those changes ever gets made, and what you end up with is, a least bad for the maximum number of people in a very unresponsive ecosystem. So the kind of problems that we're seeing today with 3D printing have existed before, and our technological foundation. If we look back at the 80s, at the desktop publishing revolution, there were 3 interesting enabling pieces of hardware: PCs, fax machines, and laser printers. Millennials in the room don't know it, but these things used to be impossible to make work, let alone work together. And eventually Mac came along, Microsoft came along, and they gave us Word and Photoshop and Excel. And those things seem normal today. There was a time when something that was easy to use, that allowed you to focus on the content and not the tools, was groundbreaking. And that's where the first birth of the tech revolution came from, was things that curated that process so that you could focus on content and not on technology. So last week at Autodesk Real, they had this new conference that they had me speak at that was all about their new mantra, which is capture, compute, create. And if we take a look at that on a more philosophical level, on a deeper level, on the meta-modernist level, It's input, interface, instantiate. And what I mean by that is it's a process where we capture data, we take data in, we sense things. We find algorithms and ways to manipulate that data and purpose that data, and we push it back out into the world. And this is very easy now with 3D printers and mechanical tools that we never had before, like CNC machines. So this process came from our postmodern forebearers, from architecture, from designers that got these tools, during the 90s essentially, and figured out how to make them do useful things. So Frank Gehry, very comfortable in his own disruptive skin, not afraid to say fuck you to the establishment. He could ball up pieces of paper and then digitize them with a digitizing pen. That was before we had 3D scanners. It was this arm that you used to have to trace the pages with. But doing that, he could create these crazy forms with amazing complexity that were beyond imagination. Now, if I tried to 3D model that piece of paper, and I'm a very fast 3D modeler, it would take me a day on like today's computers. Now, he did this 20 years ago. And so he was light years ahead based on the time by understanding how to use the tools in interesting ways. Zaha Hadid, another famous architect, was the first person to use algorithms to create design, to not design the thing herself, but to create the software that created the thing. And most people thought that that was going to be really stale and really monotonous, but it's anything but. She showed that it could be natural and organic and indicative of nature and beautiful. And then Anish Kapoor, I know a lot about because I used to make the tools that made his artwork. And we would make these giant, high-precision, geometry-worshipping stainless steel sculptures that were perfect representations of their geometry. And the reflections, being as smooth and linear as they are, is evidence that those things are built perfectly to tolerance. Now, to get them to do that, we'd have to mill them and manipulate them and polish them and then scan them again. And then manipulate them and mill them and polish them again, and then go back and forth between digital and physical and digital and physical in this hunt of geometric perfection. And that experience gave me a very unique lens on this process of that blurry line between actual things and digital things and how they relate. So there are a lot of meta-modernists that exemplify these kind of principles that are starting to emerge in the world, and I'd like to highlight a few of my favorites. So this is Keegan Schoenberg. She's got a company that's kind of similar to mine called Souls, except they do orthotics. She has people use a tablet camera to scan their feet, and then she can create custom orthotics that are 3D printed that she then mails to them. Really interesting use of how to incorporate capture and scanning in a way that's very curated for people so that they don't have to think about all the CAD and technology that's going into the printing. They're just capturing their foot and getting something that's perfectly fit to it in return. Then there's another team, Jessica Rosenkrantz and Jesse Rosenberg. They have this shop called Nervous Systems, where they make these awesome web-based interfaces that allow normal non-designers and engineers to create beautiful 3D printed jewelry in this very curated way, where those people would never be able to make these complex things without this kind of simple tool, but it allows non-designers to really take advantage of the technology and the power in it to create useful, interesting things for themselves. And that's all based on really cool algorithms that these guys have designed to take all that pain away, to take all of that skill away, and just give it to people. Then this is Savash Madhavi. He's more of an engineer, but what he's done is he's created algorithms that take metal and fit them and design their geometry based on thermal properties that he wants them to have. So this is a heat exchanger, but it wasn't designed by people. It was designed by his algorithm so that it would optimize the properties of the metal in order to do its job, which is in this case to kind of act like a radiator. And so he's surrendered that engineering control to the algorithms to let the algorithms figure out the best way for him. So with all of these amazing technologies, what are we making? Well, right now we're making really beautifully useful thermoplastic tchotchkes that year after year get higher resolution and crowd our geeked out mantle places. But that's not useful, and as Anouk likes to say, it's time for us all to stop printing bullshit. And if you want to stop printing bullshit, what do you print? And the answer is medical devices. Most people don't know this, but the two best-selling 3D printed products in the world today are both medical devices. 80% of all hearing aids are 3D printed. Invisalign braces, which are the #1 selling 3D printed product in the world, are also 3D printed. And it's because person to person, our faces are different. And by customizing things for people, we can remove the pain and the frustration that comes from one-size-fits-all solutions that within the medical space can be the difference of somebody being compliant with therapy and not compliant with therapy. It can be the difference between making somebody healthier and improving their quality of life and not. And so this is where my startup Metamason comes in. We decided to take CPAP and see if we could fix that problem. You know, given that the mouth and the ears were already taken, we decided we were going to go for the nose. And, you know, it's not just, you know, like a funny thing. People who suffer from sleep apnea have to use these horrible, ugly Darth Vader snuffleupagus masks. They have to get into their partner at night with these undignified products on, trying to feel normal, trying to feel comfortable, while they're sitting there feeling infirmed, feeling other than, with this intimacy barrier between them and who they're with. And that's tragic. It's so tragic, in fact, that half of all sleep apnea sufferers quit CPAP therapy in the first year of use. And this is for a disease that 1 in 4 men and 1 in 9 women over age 30 currently suffer from. It's a silent epidemic. So in order to improve what that feels like for people, to create a better product, to create something that was less embarrassing, more enabling, and more functional, what we do at my startup is we take a 3D scanner, like this one. We take a 3D scan of our user's face, and then we use that data to create a completely conformal, perfectly form-fitting silicone sleep apnea mask that not only has aesthetics that they can customize so it feels like them, but it's perfectly form-fit to their nose. So it won't leak. It needs the least amount of pressure to hold to their face so it won't leave marks. It, you know, is essentially becoming a second skin to their own body. And that's where the future of this is. And being able to create products that are perfectly matched to people so that they can run faster, play harder, be safer, that we can have these products that interact with us like an extension of our own bodies. And so what our goal is to create a tool to enable people to make those things, to combine the scanning, the algorithms, the printing, and ultimately the purchasing into one integrated process that is tablet-based. And so we're developing that right now. But what makes us really excited is where this is going. Right now, there are a lot of awesome tools that are coming online to allow you to do one-off simulation, one-off optimization. So we'll be able to take products and not just design them for people, not just customize them for people, but engineer them for people and then, like, optimize them for you. Make something that is, we look at how you are, what you do, what you want, and make something as perfect as possible for you. So we're not stopping at great products. We're trying to fuck great. Let's make perfect. And this is the path to perfect. So in a nutshell, this is the meta-modernist philosophy, trying to create new curated ways to allow people to use the technology, not think about the technology, create useful things for them, but without having to be masters of this stuff, to create software that just makes it, you know, just work. And that is meta-modernism in a nutshell. Bill, thank you so much.